Hi, welcome to the HBase Phoenix Birds of a Feather session. So I'm Josh. I'm the engineering manager of the HBase Phoenix team at Hortonworks. VP of Phoenix at Apache, and HBase guy who likes to he could write some more code than he does. So we don't really have a firm agenda for tonight. So usually how we have a lot of success in these is just open up to the floor and sort of let a discussion sort of naturally happen. So if anyone has any specific questions, general things you're curious about, we're happy to entertain a discussion wherever you'd like it to go. It can be high level, low level. We have the engineering minds in the room here, so we can make whatever you'd like happen. So who was the first question? One person, at least one person did. He has a t-shirt. Or he just found a table full of free t-shirts and took one. Who didn't? Yeah, would anyone have attended an HBaseCon and PhoenixCon had they known it was happening? There we go. That was a. Have to tell them next year we have to separate the cab and. So, I guess how many people care about HBase versus? Do we have a split in the room at least on HBase versus Phoenix? Who would prefer to hear about HBase stuff? Phoenix stuff? Oh, 50-50-ish. Okay. It's a good reason. That it has. So for those who entered the room here, we're polling to try to find a topic of discussion. Go for it. Okay. Mm-hmm. 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 That might not be on. Can you turn the other handheld on? Thank you. Woo. There you go.
Yeah, so the application kind of crunches data in two pieces, right? It uses a Spark engine and Hadoop cluster. That works fine so far. But primarily where we are right now is the UI leverages Phoenix into HBase to give it that query-like feel. Part of it is because the way the application was originally designed was classic, application server database. So they just didn't get to that piece yet. So my main question is around, it's trying to go against quite a heavy data set. I don't know if it's the way that the application chooses to interact with Phoenix that's the problem, or rather if it's the way that we loaded data into HBase and the row key is just not the greatest. One of the primary challenges that we have is that, again, this is sort of legacy, right? So there are multiple paths to get to that transaction definition. So there isn't like a silver bullet where necessarily we set up a single key and it'll meet all the access paths. Yep. So I'm curious around, like, what thoughts, like, at some point we got to fix it. So
yeah, no, and it's not a unique problem either. That is probably one of the most common problems we hear. You know, essentially we had some lift of some application, some code that we had already running, and we know we want to get on to HBase and Phoenix for all these normal reasons. We want to be horizontally scalable. We want to not be paying for an expensive database license, stuff like that. And so it's by no means is it a unique problem. A lot of times, it's obviously it could be very specific, a very specific problem, like you said. But most of the time, it comes from a different way of thinking that you have to, is the common denominator we see. So a lot of times the mindset you have going into these, like a relational database is you're thinking about, I don't want to have too many tables. I don't want to have too many indexes because you have some finite number of amount of space on the server. You don't want to have too much data under control of the database because you're used to thinking vertically in that sense. One of the biggest things is to try to convince people to do otherwise is stop worrying about the space and just really try to optimize for the read case. So a lot of times what I will encourage people to do is I ask them a question. I'm like, okay, for your application, what do you need what does your optimal data structure look like for a table? For some application use case, if you have a database of people, how are you going to look them up by first name, or are you going to look them up by social security number? Are you going to look them up by last name, right? Each of those cases, if you have an application that does one and you index to the other, you're scanning over the entire data set and it's never going to be fast. The big thing that I always like to keep in mind and tell people, I'm like, you're always going to see it benefit in spades if you take the extra time to just say, I'm going to just make another index table. I'm going to pivot my data. I'm going to write another copy because you know what? I have the space in HDFS, and I know if we get to a point as the business grows, I know I can easily just buy a rack of new hardware, plug it in, run the HDFS balancer, and I'm done. And you don't have to re-architect it. So a lot of times it really boils down to, what does my application really need to do fast? What is the optimal form of my data? And just implement it. Thank you for that, by the way.
So what about the Ranger policy?
So what about the Ranger policy? So at the HBase level or Phoenix as well. So Phoenix level, we have some growing that we need to do with the Ranger team, essentially. So inside of HDP, we like using Ranger, obviously. There's been some growing pains in making sure that both HBase and Phoenix, from the Apache side, other folks also buy in and say, hey, we're going to get behind Ranger as a centralized authorization system. So specifically, some of the things that we have to sort of navigate, which is difficult for us, is to say other people in the community don't always want to use Ranger. They're either happy using the HBase native authorization, or they don't need some centralized authorization, or they're using some other software period to do it. So one of the struggles we have, being a small team working on this stuff, is we want to be able to build in support into Phoenix to do stuff like having grant and revoke is one thing that some new syntax we introduced to Phoenix's SQL specification, but we also have to make sure that all the stuff that other people are doing still works with this. So we had to spend some time working with the Ranger team to start saying, hey, we have some new APIs that were added in by the community. We got to make sure these are all working. We have to make sure these are all configured so that Ranger knows that they exist. So there's a lot of back and forth here. And the really big gaps in Phoenix right now with Ranger stem from that sort of problem. But I had a good talk with some of the guys internally at Hortonworks who work on Ranger the other week. And I think we have a plan on the roadmap to sort of how do we get better at this? How do we go and fix this? For now, it is a little dodgy for the basic use cases will work with it, but there are definitely known holes that we have in the implementation that we need to plug up.
Because in our organization, security is a big thing, and then if anything is not as per the security, then they will not allow to implement that.
So we are not aware of any holes that would leave unauthenticated or unauthorized endpoints or access points to the system, but it would not all be centralized via Ranger right now with Phoenix. So there would be certain things you would have to configure via the HBase native authorization to make sure that those aren't or they have some policy that you have to that meets whatever your business level stuff you have.
So I'm curious if anyone has a need for location-based access to HBase. In particular, these networks can access these tables or this region server or whatnot, or if everyone's pretty happy with, hey, I just need read or write by authenticated users and I want to just do that.
The network itself is taken care of for the most part around where, like our network obviously is quite secure. So it's all segmented, fragmented, and all that good stuff. So we wouldn't explicitly need like HBase to take care of it for us. Right. Right. Yeah.
So in my case, we're using Thrift running on the edge node with everything firewalled off due to historic reasons, and then it's basically an IP-based ACL, just using IP tables. Yeah, and then it's up to the end application to handle the Windows authentication level stuff.
You're bringing this up because in Ranger you can do that.
Yeah, so it's something that I actually have a need for. It's just something I have a need for in a cluster, and so yeah, I was looking to just hack on something either with Ranger doing it or in a coprocessor, and Artem keeps pushing me, hey, would you please use Ranger for something, man? So just curious if other people had need for it. Figured
Artem
I'd
is
see.
a very pushy fellow.
He is.
Hi, so we are working on building an application. We started using HBase long back because Phoenix was not there. So we primarily use HBase to store the data and use a lot of REST APIs on top of it. So we built this application, and then it was a single GET request. So you have just one point query, and you get to do a GET on the table, and it works fine, right? So we were able to get like a 35 millisecond performance on that, so it worked great, right? And then the use case expanded. Everyone was,
As it does.
happy to see that results, and they said, hey, can we now, rather than doing just one, can we do like 50 or 100, like or 1,000, right? And then what we did was we tried to do an mget on that, right? Because hey, 35 milliseconds for one, and then we saw that the performance varied, like for 100, we could get like 9 or 10 seconds performance, and it was not acceptable because no one will wait for 10 seconds on a critical application. So what do you think we should look at, or in designing this, or anything that you want us to go back and look at?
So the one thing you have to be aware of is batching is good up until a point, like, right, so batching is this balancing act between improving throughput at the cost of latency. So you can reduce the overhead to functionally, you're reducing, say, the number of calls you're making on the network to access some data. If you have 10 rows you need to fetch, you can put them all in one request, and you have one network cost, and that's typically something fixed with respect to the amount of data you're reading. Whereas if you're only doing one per, you're still paying a slightly overhead for doing that 10 times instead of just doing one. But like you said, there's always that sort of balancing act of how do we, what is the sweet spot for what your application needs, what your users are going to expect. The other thing you sort of have to worry about too is when you start over batching. So we had a really fun case recently where we had a customer who was having a lot of region server crashes, and they're really worried about this. What's going on? Why? We wake up and suddenly there's 10 region servers gone, or there's 20 region servers gone, and it's different every day, and they're very upset. Why is this happening like this? And it turned out what it was is the client was just over batching requests and sending 10,000, 15,000, 20,000 in a row. And then the fun part is that they had a really small timeout, so the client just said, oh, I didn't get a response in 60 seconds. Let me try that 20,000 requests again. So suddenly then they just have every single region server is falling over because they just ran them all out of memory. So there isn't really a good answer for that. It's definitely very much what are the sort of business cases that you have to support, and The other thing would be making sure that when you have to do many many lookups all at one point in time, that they're not all being funneled to a single region server. So making sure you'd have enough distribution in your row key space, that you're actually spreading them out and using that your entire set of region servers and not just one.
Okay. Thank you.
Yep.
For the HBase table compression, what is recommended compression? Currently we use Snappy. Is that something better than?
So Snappy is a very nice middle ground when it comes to compression. So when we're dealing with compression, you're fighting two things. When we're applying compression, we're reducing the space usage of HBase at the cost of a slightly higher CPU usage because we're decompressing every time we need to read it. So the balancing act there is how fast is our compression algorithm and what's the latency of an application. Snappy is very middle of the road where you get pretty good compression without paying too much cost to decompress the data. Whereas, no compression is obviously the fastest, but takes up the most room, compared to something like bzip. It's going to be dog slow, but it's going to be smaller. So Snappy is a really nice middle ground in that sense, where you get some pretty good compression, but you're not paying an arm and a leg to get it. The only other one that's sort of come up is LZ4. Is that what it is? I think. LZ4, I think, is another one that came up, and there's like natural support via a Java implementation that you can come up through the Hadoop codec API. LZ4, I think, was certain use cases where it was slightly better than Snappy. Most of the time with these benchmarks, there are certain cases where one would be better than the other. So I think Snappy is, if you guys are running, you have it working already, I think Snappy is a great choice. If you're looking at something else, you can obviously try it out. Some of the other ones, it's a really, that's one of those fun things you can sort of sit down and benchmark, and if you come up, what does my data look like? A lot of the times, certain characteristics of your data may compress better than others, just how that compression algorithm itself is implemented. Thank you for the question. Everyone else too, by the way.
What is the fate of C++ client?
So the C++ client is in a state of, it can support reads and writes, but not table administrative operations, if I recall right. So it implements your normal scanner. You can do puts, you can do gets against it, but you couldn't do something like create or delete a table with it. I believe that's what it is. In the community, it's still kind of failing to get a lot of people behind it. So I think, we were my coworkers here at Hortonworks are the ones who did a lot of work to try to make that happen. We've not gotten a lot of backing from the community behind it. I know with HDP specifically, we have started shipping a shared object as well as a statically compiled library for that client. But that's sort of, it's stalled a little bit, I'd say. But what's there right now does work to the best of my knowledge. The question was, does it support filters? And I believe it does. Ennis over there might remind, yeah. Yep. Okay. Cool. Thank you.
What is the best way to access HBase from Java Spark?
So from Spark, so you have two sort of options when it comes to Spark via HBase directly. One is the HBase Spark connector that's out in the Apache, and that implements the RDD API. Hortonworks also has the Spark HBase connector, SHC, which implements the Spark data frame API. So I am by no means a Spark expert here. I think Artem might actually know more than I do, but.
The question was for Java. So does the SHC support Java?
That I actually have no idea at all. Java over Scala. I'm not. That I'm not sure of at all, actually. I'm sorry, I misinterpreted your question.
The first one, I believe, supports Java.
So you think the HBase Spark does support? Okay. So that one, that it will be shipping in HTTP 3, the HBase in HTTP 3. I don't think that made the Apache HBase 2.0 release. I think that's something they're slated that for like a 2.1 or a 2.2 release. I think there's something else that somebody in the community wanted to do before they shipped it. And I don't remember exactly what it was. But I know we do have tests internally for that do exercise that. So I'm sorry I don't have a better answer.
The answer is we don't have any options.
So I'll ask a question. How many people wish they could run HBase on the cloud, on like EC2 or GCP? How many people are thinking about doing that in the near future? Sure. Yeah. So I say as long as by Azure you don't mean HD inside. So yeah. 2. So okay. Out of curiosity, do you have a like high level what your motivation is? Like what is is it cost? Is it flexibility and scalability?
For us, the flexibility right now and cost as well because, so depends on, we want to have our own subscription and our cloud team is actually pretty strict about certain things. So last year we had a security incident and they're trying to shut everything down. So right now it's mostly on but we have an HBase instance running it in AWS right now. So
Neat.
yeah, not much usage though, but yeah.
Gotcha.
Mine's mostly managerial pressure of move all the things to the cloud.
Interesting. Okay.
Manager.
You're good. Yep. Oh, that was it. I thought.
So there it is. Managerial pressure to move all the things to the cloud is pretty much the only real reason.
So trying to read between the lines there, does that mean you're feeling that there isn't really a good technical reason behind that, or?
So the only good technical use case is the fact that being able to scale and all of those other nice to haves of being able to spin up and do ephemeral sort of stuff.
Yep. Okay. Cool. That's one of the things that we had a really good conversation at the end of the day on Monday at HBaseCon and PhoenixCon. We had a really nice discussion with a bunch of big, long-time HBase users where we kept coming back to this point of, how do we sort of make HBase a little more flexible in how we deploy it, and what are the sorts of things we should be focusing on rebuilding inside? Can we do something to get HBase off of HDFS directly? Can we get rid of that requirement? If you're on-prem HDFS, it's great. But in the case where we're on a cloud provider, we probably want to use some of their distributed storage because we don't have to think about it. It's cheaper. We can spin it up. We can spin it down. If we're only doing a workload for a month or two, then we can just go and drop the data. We don't have to have that extra burden associated with managing that. So that's one of the big things we're thinking about here. So the current state of options for running HBase without HDFS are limited right now because HBase itself still requires a very specific file system implementation for its write-ahead log construct. So inside of in HDFS, the API is there. They have a file system API, and they have some fsync type semantics. And their HBase itself has some very strict requirements that the file system must act in a certain way when it uses it, and that's essentially how HBase guarantees that in the face of a region server going up or down, we make sure we didn't lose any data. The big thing with some of these other file systems that we have, S3 itself, and WASB is actually probably the only one that I know of that actually definitely meets the strict requirements. And that's based off of a lot of engineering effort from folks back in the day. But for the most part, the big popular ones now, they don't they don't meet that level of stringency because they're trying to optimize for availability. So one of the things that I've been thinking about a lot lately is how can we write HBase in a way that doesn't have that requirement on HDFS for the write-ahead log. So what could we implement instead of a traditional file-based approach to sort of swap in something else that would give us the same durability semantics, but give us that flexibility that we can just say on an instant, spin up 5 more region servers, or, spin down 3 region servers. So, so Accumulo is not any farther along than we are, than HBase is. At least if people are, I haven't heard anybody doing anything differently. I actually don't know how Cassandra does it. I think they have their own sort of ring write approach inside where they're owning that entire process. What we've been thinking about internally at Hortonworks here and trying to make this a reality is using a Raft, the Raft consensus protocol implementation. So some of our nice coworkers who work on Hadoop and HDFS have been working on this incubator project at Apache called Radis. So the thought process we have here is if we could embed this client library inside of a region server, we could kind of have that same architectural approach where everything we need is self-contained inside of a region server. So region servers can sort of talk to other region servers to create a quorum, and we can get that durability, that consistency, a number of replicas for the data we're using just by using local storage then. So that's one of the long-term polls that we have sort of working for us here, but it's always interesting to sort of see the difference in, you can go from one end of the spectrum where people are like, I am completely happy with on-prem clusters, I have a data center, I have budget for power, space, and cooling, I am happy as can be. And then other people, who, I got my manager breathing down my neck, I got to turn on the cloud in like 3 months. So it's always interesting to see, from my point of view, what are these really driving factors?
We're currently using HDI clusters for like 24/7, 365. And just curious thoughts, good or bad, on that, because I've kind of gotten some feedback that we're using it in a way it's not intended to be used. It's more to be spun up for several months or something at a time.
I think it's the good or bad would be depending on your budget. I think that's the HBase running inside of HDI is just it's the same exact HBase as what you get if you installed HDP by default. So I don't think I wouldn't look at it in that stance. I wouldn't say you're necessarily doing it wrong or anything like that. I think it's really a financial decision at that point. Can you optimize, and sometimes that comes down to the simplicity of just leaving something on. Is even though you're paying more to do that, the big picture, it still could be costing you less than having some ops guys that you're paying to keep, doing that, the legwork of spinning up and spinning down. I'm not the person to ask for, what all HDI, how easy HDI makes that to spin stuff up and spin stuff down. I know you could very well keep that data on the file system that they provide for you, and you could keep it around and do something like that. But I'm not sure how easy they would make that for you out of the box. There we go.
With apologies, because this is something that I know I'm planning on posting to the community site as a question here, but the issue just popped up this week. We have, as I mentioned, Thrift 2 servers that we communicate to, and we're writing to a mob table with mob enabled, and we've noticed that we're running up against the maximum record size. We've changed it in Ambari and rebooted everything, and we're still hitting that same issue where it says the key value is too large for that cell. For the cell size, it's the key value record is too large. Unfortunately, it's also a 2.5 HTTP cluster. Another battle I'm tilting at right now.
So I wouldn't know why if you set that property, so if memory serves, the HBase has the value or the limitation based on the size of the key. So then the mob is really meant to, supporting cells that are 10K to, maybe tens of megabytes of data. But the cell or the key size is still, I think the false limit is 1 megabyte if you put over that. But it surprises me that if you made that configuration change, restarted HBase, why you wouldn't see that again. So that could be something as simple as just a bug, or even maybe just a typo or something in a configuration key. I wouldn't know why.
We used Ambari to make the configuration change, so it shouldn't be a typo, I'd hope.
I don't. Does it actually have that property exposed?
Yes.
Oh, interesting. Okay. I thought that would just be a custom thing you had to enter.
No, it surprised me as well.
Oh. Okay. Yeah.
So
now in that case, it sounds like a bug to me, but I have to look into that some more.
Okay, I'll send it to the community site then. Thanks.
Sounds good. Thank you.
So we started using HBase. We had a bunch of tables, right? And then we went to, I don't remember, 2.4 or 2.5 where Phoenix got introduced. And we started trying out Phoenix tables. We did hit a couple of bugs at that time, like the indexes were not working, and we scanned and it was like a known issue. We do have the latest one, HDP, but we haven't tried if that bug has been resolved or not. But my question is, what's the general direction right now on using HBase versus using Phoenix? I know that there are certainly places where we can use HBase directly and it performs, way better than HBase, and vice versa.
Mm-hmm. Yeah. So the ultimate question is, how do we see people choosing HBase over using Phoenix, right? It's definitely one of those things of it depends on what your level of expertise and how low you want to go. And absolutely, if you're really digging into HBase and you're doing stuff by hand, you most likely can get better performance than what Phoenix would give you out of the box if, given enough time and energy. I think the reason we start seeing a lot of people, I'd say a majority of our customers that we have coming to us through HortonWorks using HBase and Phoenix, we've definitely seen the Phoenix users growing. And the number of support cases that we'll get in has really gone down from the HBase side. And Phoenix is typically one of the things where it's always in the mix, up to the point where we actually, if you go and pull down an HTTP 3.0 when that's officially released, and you start looking at it, to the point that Phoenix is now going to be installed by default on a cluster. It's no longer a thing you opt in anymore. That's sort of just how common this really is for us. When it comes to making the choices, though, SQL definitely provides a level of comfort. So there's something really nice about helping speed up users who want to build some sort of application, having the relational model behind that to help you sort of visualize, this is the problem I'm trying to solve, and this is how I can do it. Having that sort of high-level API really goes a long way, and that's what we see over and over again. It gets that level of, it's sort of like a comfort blanket or something, It gives you some guide rails. It helps make sure that you're going to be on a path that is pretty reasonable. And for the most part, your common operations in Phoenix that you're going to do are actually implemented quite well. So in some cases, if you tried to do something by hand in HBase, Phoenix actually might beat you if you did something equivalent. In the long pull, if you really invest enough time, you can probably optimize it and do it better in HBase yourself. But it comes back to that sort of the point earlier, time and effort, the big picture of how much energy that you're investing into solving a problem. So we definitely see a lot more growth in Phoenix. We've invested heavily, specifically around secondary indexing. I think I could probably feel Sergey up here groan when he says I ran into a secondary indexing problem. But we've, both on our team itself as well as a lot of the developers coming out of Salesforce as well, they've been really pounding on the system itself and the implementation, making it as rock solid as can be. So I think it's definitely, we'd encourage people to use Phoenix over and over again, just because at the end of the day, it's going to help you sleep better, and it's less you have to dig into. It's going to be a nicer experience.
Thank you. I have one follow-up question
Sure.
too. So we have seen few scenarios where Phoenix was being used as for reporting tool, and it did not go well, so they had to redesign, and then ultimately Phoenix didn't work out. There are several instances like that. So right now with the latest fixes, do you see customers using a reporting tool and connecting to Phoenix and that being successful across the industries?
So can you give me an example of what you mean by a reporting tool?
Let's say there is a Power BI report or a Tableau report.
Okay.
That's connecting to Phoenix JDBC
Mhm.
and then getting the data out.
So there is definitely, I have no hesitation in saying that Phoenix is not a general purpose relational database. I think, most people, it's, one of the old catchphrases for Phoenix was, a SQL skin over HBase. And really what they were trying to get at between the lines there is saying Phoenix gives you a SQL access to it, but you still have to know that HBase is riding under the hoods. Because the reason you have to know that is because to really optimize a Phoenix query, you have to understand how does HBase work and what is my Phoenix query really being mapped to when I go down to HBase. So the naive sort of case is if you have a 100 gigabyte table in Phoenix and you have no guideposts for statistics written in Phoenix, what you get is you get one single scanner reading over that one table. And you'd sit there and be like, man, this query is taking a long time here. I got one thread reading 100 gigs of data. So there's certain things you have to sort of know and understand how to really optimize to make Phoenix successful. One of probably the biggest limitation in people who will lift some general queries out. So BI tools are one really common thing where they have programmatic generation of saying, this is how Tableau generates a query to do some heat map or something like that. They have these very standard queries, and traditionally they aren't the nicest looking queries in the world. There are things that are, 8 to 10 nested joins with all this stuff. And while Phoenix, it's not a matter of, does Phoenix support joins or, does Phoenix support this or that? It's more so, what can Phoenix execute efficiently within the constraints of HBase? Because we don't have that distributed execution engine, something like a Hive or a Spark has. We're essentially working in whatever your client JVM has, or what can we sort of push down as like a predicate into HBase region servers itself. So a lot of times things we don't have, like we don't have any sort of distributed shuffle or any scatter sort of support. We can't farm this stuff out and dump it to disk or anything like that, because at any point your region might move to a different server and then suddenly that local cache of data is gone. So there's a lot of architectural constraints in the types of queries that Phoenix can efficiently support. So usually, I'm not surprised that sometimes BI tools like that, if they're generating queries which just are really excessive or really robust, have no component of human generation in them, they tend to not work very well on Phoenix. But typically you can, if you apply that sort of domain knowledge that we have as HBase experts, we can look at them and say, well, I see this is really what that query was trying to do. I know I can rewrite it. I know I can create a table that is going to, to your initial question, like, I know I can restructure my data in a way that is going to be effective for this. I know I can say, I was like, okay, I care about these 3 columns. I know I can push these into the primary key constraint, and I know that eventually this is going to decompose down to a range scan, or something like a skip scan, something like that. So we have seen success with people who do reporting stuff who are building it on their own. So people who are coming up with nightly queries, maybe they're using some orchestration framework to say, these are the queries we're going to run automatically, and make their own sort of custom dashboards. Throw it up something on Zeppelin or something like this, where they can go and have something ready for when a user comes in the morning and logs in. You have a pre-generated report. Does that make sense? That distinction?
Thank you.
Yep.
Just a general question. when I'm thinking, at least when I think of Hive and I think of HBase and everything, and to your point earlier about everything ultimately residing on HDFS, for me, the issue is that I have two representations of the data for my application, right? I have one that's on HDFS and it reads files and life is good that way.
Mhm.
Then I have another representation that's using a combination of Phoenix and HBase.
Yep.
Is there a way for me to easily just map the HDFS file to supply both needs as opposed to have two replicas or possibly three?
There's a lot of good questions in there. So the short answer is right now, no. One of the things that we've been working on trying to make better is the connection between Phoenix and Hive. And the interesting part is that it's not because we want to query Phoenix tables using Hive. So, you know, that's the gut reaction of the people like, oh, sweet, I can just query, I can do everything through Phoenix or I can do everything through Hive. And it's really not the point there. The reason we like that adapter is because it acts like a sort of a bulldozer for us. We can have a means that can transfer our data between these systems while preserving the schema. So we can say something like, I know I want to do some extraction of data out of HBase because I know Hive can do it better. Or, you know, I want to go and export it to some other system. I want to go and throw it into LLAP and, you know, support some other sort of use case that HBase wasn't well designed for. So that's sort of the one side of trying to give flexibility in moving data to the system which makes the most sense for the type of workloads that you're doing. However, one of the really cool things that I think we could start doing in the future is giving us the ability to manage and own that relational schema. So almost more like a lineage sort of thing. So knowing that we've had some data sitting in Hive and it was sitting in some CSV representation. You know, maybe we took it some org file, you know, we made some org representation, you know, maybe we took a subset of that data and we pulled that into HBase and Phoenix because we knew we want to run low latency queries on that. We're going to support dynamic updates and deletes, and eventually we say, man, I want to merge that updated data set back with that original org, but you know, how did the person who did that originally remember that, oh yeah, that was how we got that data there? So there's some interesting stuff I think we could start to do to say, you know, how do I manage my schema evolution and where my data has been flowing through the system? So some stuff like Atlas would be interesting in that regard for us. I think, you know, pie in the sky, I'd like to someday even see some sort of custom JDBC driver, which could even start saying if we had that system of knowing which data is where, some data is in Hive, some data is in Phoenix, and you execute a query and put it in, and we can just automatically figure it out for you and start saying, oh yeah, we see you're running we see you're doing an analytical style query. We see you're doing something that HBase isn't really going to be able to handle well. We can kick that over to Hive. We can run it there. We can do similarly if someone's doing a point query in Hive, you know, we can say, oh yep, we know we have the newest data over here in HBase and Phoenix. Let's service it from there.
Yeah, because I mean, that's basically what we do it manually, right? Like we load it in all the places that it needs to go and run the appropriate tool against it.
Yeah, I would love to actually, that's one of those really neat problems. I think we could, we have the tech. It's just making that easier to use and not push that onto you to have to own.
So follow up to that question, do you see customers using that plugin to load from a Hive table into Phoenix? And, you know, it's not bulk loading. So do you see that at all coming across?
So there are definitely two use cases for, you know, moderate data sizes. You can do a direct load from the Hive side. There are certainly the cases where you are doing a large generation, something big enough that you wouldn't want to, and you dump it out to a file and just use the Phoenix CSV bulk load tool instead. I think. You have anything or you would add to that? HTTP 3.1, right?
So I have two questions. To your points, like since we have the Phoenix Hive integration, where does the HBase Hive integration come in? If you want to like do analytics on the data in HBase, does it make sense to like have the data in HBase and also use the integration to like have the data in Hive and do analysis on that?
So the biggest difference between the HBase Hive connector and the Phoenix Hive connector is the representation of that data in the table. So when we're doing the way the Hive HBase connector works, it is expecting a very specific schema of what is in the row key, what's in the column family, what's in the qualifier, what's in the cell. Phoenix has its very own. If you've never looked at a Phoenix table or the HBase table that has Phoenix sitting on top of it, you'd look at it and you're like, oh, this looks really weird. So Phoenix does, one of the things it does is has the ability for compound row keys, right? So you can specify multiple columns to be in the row key. And all of these sorts of little tricks that it's playing are typically done via some binary encoding. So it'll have things like 0-byte separators in between the values for that are making up that compound row key. Whereas stuff in HBase, they typically have more ASCII representations. So, if you store a number via the Hive HBase thing, it would store literal as like the character 1, whereas Phoenix would actually store like the 4-byte representation of the number 1. So you have very subtle distinctions there, but it's more so people who have data that they manually wrote into HBase would tend to use the Hive HBase connector because that doesn't have as stringent requirements on how the data representation works. People who use the Hive Phoenix stuff, they already have data in Phoenix that they're using, and they either, they want to do some extract or they want to just do some big shuffling of data in between these two systems.
And the second question has to do with if we're trying to get data, if we're trying to like write data into HBase with MapReduce, like has the bulk load API. With Spark, like with the SHC, we kind of realize like multiple connections is like created when it's trying to like load data into HBase. Is there like a workaround for that?
So there have been bugs in the past where, at least they know with Zookeeper connections not being closed properly in the Spark adapters. So in that one case, there may be an issue just with a known bug that's been fixed since then. I don't know with the parallelization tools that you have in Spark to control the number of executors and how many, actual tasks will spin up when you start a Spark task. I don't know. I'm looking at some of my guys on my team here to see if who I always go to for the Spark stuff.
Clay told me there's 140 open issues on the SHC.
So the way I would expect it to work anyways, I can go from this out, you'll have some amount of parallelization, right? That Spark will do. You take your driver, it's partitioning your workload, you're spreading it out, just normal mapping sort of our paradigm that we're used to seeing. Each of these would have some connection, and if you don't have a strong sense of data locality, what you have is this sort of crosstalk. So one Spark driver might have to actually be connecting to 5 or 6 different region servers. So you get this really big, almost Cartesian product looking thing where you have lots of clients talking to lots of region servers, and that can have a pretty dramatic increase when you're not working in the same JVM. So under the hoods inside of the HBase client, one HBase client will never have more than one socket connection to a region server. So when you're operating in a local standalone application, you don't see that sort of crosstalk because all of your connections are managed there. So you never have more than one connection or in a region server, and then HBase is doing the multiplexing of saying, yeah, I see you have some threads running. They're all going to batch into this one and ship it all in one go. You don't have that when you're running in separate JVMs then with these Spark executors because they don't know that the other exists. So I think, I don't know of anything specific, but I think you definitely would see a heavier impact on an HBase cluster as you ratchet up Spark parallelism. I can say that definitively.
And have you tried this Spark Phoenix connector? This is it's more recent, so I have a customer who said to me that was a lot easier to work with, but they didn't report the same behavior. So I'm just curious here.
Any other questions?
Is there a way to model in Phoenix when you don't know your columns?
Is there a way to model in Phoenix when you don't know your columns?
When you don't know columns? Oh,
Yeah.
dynamic.
Yeah.
Dynamic columns feature.
So, yeah.
Yeah,
So,
yeah.
so one of the neat things about Phoenix is you can actually specify columns in a query that don't exist in a table, which is really goofy. I think that was probably one of the biggest reasons that it came out of Salesforce in the beginning. It was one of these like novel features of why people picked up Phoenix way back in the day. Is you could actually, if you had some table with columns, A, B, C, you start writing data, whatever, and say your business need changes, and you didn't actually need to do something like an alter table to start writing a column D or a column E. So what you typically, the use case we typically see is you can avoid that alter of a table to explicitly add that new column to the schema, and you can work around that and expose sort of sets of dynamic columns which sort of might exist for some rows. So this is all going back to the fact that HBase is a sparse column restore, right? We can handle the lack of a certain column in certain rows, and we don't care. You can create a view on top of that table which says, hey, I know most of these rows have columns, have a column D. So you could create a view on top of that base table that has columns A, B, C, and D without ever doing that initial alter of the original table. Does that make sense? Mm-hmm. You could do that, yes. So repeating that there, essentially with the dynamic columns, you can specify it in the query itself. So you can say, I want to read this table and specify the columns and the types of each of those columns in the query as you're reading or writing data. But if you use the view, then essentially you would not have to specify that every time you're trying to read or write data out of there. The view manages that and tracks that state for you. Good question.
I actually want to do a poll here. Does anyone know if you can work with Phoenix and Python? Is there a need for other language than Java, for example?
Actually, what's your favorite non-Java language to write code in? The old guard appears. JavaScript? Oh. Node.js.
Go.
Ruby? See, now I got you trapped. Okay.
Did you know there's a Kafka plugin
For
for
Phoenix.
Phoenix?
Oh. Pom. So Ruby, anyone ever want to write a Ruby on Rails app that backed by Phoenix? I think that was a no. Yep. Nope. Okay. That's completely fair. It's I'm trying to think what else. Yeah.
I have a more generic question. So,
Okay.
do we think that going in future there can be another data store that can supersede HBase?
MongoDB.
Playing devil's advocate, I think technology is, there could always be some crazy paper that comes out of a Google or Facebook or something, and they magically unveil something that they've been working on for years. You know, I completely pragmatic there, and math and science could come out of the woodwork and bring something brand new. In terms of what exists today, I think HBase fits a very good niche that is very well defined, and I don't see other competition coming in and booting it out. I think we have a very firm grasp on this low latency, high throughput, consistent store. And I don't see that changing. I think the really big thing that worries me actually is how do we make sure that when the computing platform itself is changing, how do we make sure that HBase still can run on that? So that goes back to the topic I was trying to get people to think about earlier. You know, how do we run HBase better on the cloud? When we're talking about infrastructure, that isn't physical. You can't go up to a rack of computers and touch it anymore. You know, getting ourselves out of that mindset there to say, how do I go and run HBase on EC2? How do I run HBase on Kubernetes? How do I run HBase on Yarn? How do I do that? I think that's more the issue. I don't think as tech anything would come out and replace HBase, but I think HBase itself needs to evolve to make sure that we can still deploy it in all the ways that are most cost effective and functional for people. That's a good question though, thank you.
Job security.
Also be able to support low latency.
Compare HBase to Druid.
Okay, go ahead. So I'm not, I'm sorry? Mm-hmm. So I'm not a big expert on Druid. The most I know about Druid is that it was more for the Hive use cases to help support OLAP cubing type, so high dimensional analysis of data sets. So automatically, and I'm going off memory here, I believe it's something, the way Druid sort of works is that they support, they're building a lot of these dynamic indices on each of these dimensions of some sort of data set. So they have this much different representation of the data. As far as I know, they would support low latency reads, because essentially what Druid's doing is the same sort of notion actually what I was suggesting earlier. They're just building out these different facets of the data, these different representations that's optimized for each one of these dimensional slices you want to take of your data. That's my understanding of how Druid worked, but I am by no means an expert. I've listened to a talk or two and read a paper.
Druid is made to make fast queries to the data, so it aggregates the data in real time. So if you don't need to query like specific data about a person, but how many clicks has a person done during the last minute or hours or weeks. It aggregates the information in real time based on that time window. So you don't have to go to Hive, for example, to query and aggregate the information every time. So it's always pre-aggregated by that amount of time you want. So the use case is quite different from Phoenix, because Phoenix is more to look for the needle in a haystack, yeah, and not aggregating information.
Aggregations, right? Aggregations over time is really big, yeah.
Different applicability for what you want.
Thank you.
Sure.
So if you have a use case where you can, denormalize the entire data that you have. So because you're just removing the number of joins that can happen in a database or in a data store. And if you have a time series data, so then pretty much in the conversation what I feel that Druid will become better option in that use case in comparison to HBase. Are we talking about that?
So I think they would be, I think they would ultimately, in that specific use case, they would be functionally implementing or solving the problem in a very similar way. I think the understanding of what they would have, I don't know which one would actually, you know, outperform the other in that regard, but I think they'd functionally be doing the same sort of thing under the hood, where you'd be defining that compound index, and you'd have the ability to do very efficient range scans over very small subsets of the data.
But the difference is because in HBase is doing a linear scan, but in the case of Druid, we already have a bitmap, which is the bitmap tree. So don't you think the scan would be much more faster in Druid as compared to HBase?
Only if time was a leading component in HBase, it would still be fast from the HBase. So you'd still have the login lookup into that to find that start of that data in HBase itself. So you'd still get the partition pruning of the regions itself to get that small subset of data, but if you wanted to do, that would be optimizing for time, right? So if you ever had a query then where time wasn't the component you want to use, you'd have to have some other pivot, you know, for your other dimension being a leading key in the table. So I think what Druid essentially is doing is it makes that each of those dimensions, you know, which dimension do you want to prioritize? It's building those for you automatically and giving you that nice API for those aggregations over time and making that nicer. I think HBase, I guess, I would say is a little bit more low level in that regard. And Phoenix, you could do a similar thing, but you'd be doing it by hand, whereas Phoenix or Druid would put a bow on it for you. I don't know. How long do we go, Artem? I don't know.
Started talking about log event.
Time series implementation on top of HBase for database?
So the question is, you know, what kind of time series options do we have? HBase has probably the most well-known one for HBase is OpenTSDB. The big problem with OpenTSDB, why we don't have like adoption of that in HTTP specifically, is because it's GPL licensed. And last I remember, the author was very adamant about it remaining GPL. So that was a big sort of problem of like, it's not gotten a lot of adoption from folks because there's all that, the very heavy copyleft side of that where we can't safely redistribute it without polluting everything else.
Right. In HBase, we added data compaction specifically for time series use cases, and I do see customers using HBase for that. And you know, there's a talk from a year ago, Vlad basically speaking, how do you make operationalize HBase for those use cases, and there's like a schema design and you know.
Usually in the same table as the data itself, or they create a different table for time series, or they mix and match.
It's mostly, so it's less, at least comparing it to Timely and how that works. The stuff that the presentation that Artem's talking about was very much just how do I take I have one specific table which does time series data. I think Timely is another product that's specific to a Cumulo, or built on top of a Cumulo, and they have some like integrations with Grafana and some other stuff like that. I believe what they were doing is they also have windowing and aggregations that roll up to like 5-minute, 10-minute periods, and they have some special functionality in there that automatically build those on the fly, if I remember. I haven't obligatory. I know some of the guys who worked on it, and that's about, yeah. But I think the primary thing of what the HBase side was doing there is essentially how can you reduce the I/O amplification from that typically happens with time series data. So the problem is, you know, essentially if you have data that you wrote 1 week ago, you're never going to update again. So every time a major compaction would happen, you're recompacting more and more data intrinsically. So some of the date tier compaction stuff, which was actually something we stole out of Cassandra, an idea we stole out of Cassandra was saying, we know when we can effectively say, we have a write once data set, we're not actually re-updating this old data, we can start managing these H files inside of the regions a little bit differently to reduce that write amplification. And ultimately, you're just reducing how busy your cluster is. And you can have some pretty impressive improvements in the amount of data you're servicing, as well as how quickly you can just truncate a data. So like if you have an age off or TTL, you can, in optimal cases, just delete a file because we know a specific time bound of what is contained in that file. So we now don't have to like submit deletes. We don't have to rewrite data like the compaction process normally would in HBase when we have essentially it's applying time ordering to certain files, and then we can play tricks around that to do stuff more effectively. Cool.
Are there any features in HBase or plans to add any features for geospatial queries on HBase?
Oh, where's my buddy Jim Hughes? So I had a very long talk yesterday with Jim Hughes, who is the one of the major authors of GeoMesa. So GeoMesa does a lot of work with having geospatial APIs and tools on top of a variety of data stores. And I know they do stuff with HBase. But I had a very long talk with him about all sorts of stuff that he was trying to add and how they can sort of build this on top of HBase and stuff like that. HBase's stance as a community is sort of that it doesn't care too much. It just wants to be a platform which has these very clear distinctions. This is what we support, and this is what we do really well. So I don't think we're seeing anything that would come out specifically as like endorsed or promoted by the HBase project, but I think you'll definitely see GeoMesa is one that's really common that I see time and time again that has some amount of community adoption behind it that does work very well. Bigtable or HBase itself as an architecture does have custom indexing strategies which can be very efficient, doing bounding box Z-order style representations, which can be quite efficient.
Thank you. We'll take one more question and then we got to wrap it up.
Fight! We can talk more in the hallway.
Does multi-tenancy come in a way in predictability of response time of HBase?
Absolutely. So probably one of the biggest things, biggest problems when having a multi-tenancy, or just many users using the system at one time, is when one user gets greedy and stomps on the others. So that use case I was saying earlier about how that that one cluster was brought to its knees because that one bad client. That is the primary worst case scenario for multi-tenancy here. There was one specific application which just had this bad config and was just written crappy. It just said the developer is just lazy and said I'm just going to batch all this in one go and have fun. That was the one case where he actually killed every single job that was trying to happen in the system, was causing these outages here. But the way we ultimately solve this is by implementing some RPC quotas. So that was one of these really nice validation points where we actually could say, hey, one of these tools that we built effectively for making sure that users aren't squashing other users in a multi-tenant system, that actually worked. Once we got that running, we had the point where we could say, yeah, well, that guy's job might not run, but we don't really care about him because he was being a jerk anyways and trying to do something he shouldn't have been doing. So it's definitely, we have knobs and features inside of HBase which can help there, but a lot of them do require some amount of understanding what your requirements are and what a user is actually allowed to do.
Can there be multiple region servers in a node or no?
You can have multiple region servers in a node. There is, it would not fix the problem because, or at least in the example that I'm painting here, this real world scenario, if you have multiple region servers and somebody's still doing something bad and knocking over a region server, it's no different than having more nodes.
Just general question around releases, right? So there are times when, there are times when like the community would fix some bugs that would, still be in the current version of whatever HTTP minor release or major release we have. Is there any, I guess what's the best way to address that? Do we need to wait till the next release? Can we just go rogue and install community version that fix the bug? What are your thoughts around that?
Don't go rogue. The best case for us is It's very rare for us to go and approach a known issue that's been, especially one that's been fixed in the community, and it's very limited situations where we would actually say, no, we can't actually backport something. Usually the only reason that comes about is when there's some reason why that was implemented in such a way that wasn't backwards compatible. So a lot of the times that's either inadvertent because HBase itself doesn't, tries to be very good at not doing that, or there was some fundamental reason why the old way of doing it didn't work. So it's very rare. Sometimes, we may backport something and say, hey, this doesn't meet the same bar of backwards compatibility that we try to ship inside of HDP. But the problem that we also have, if people do try to install newer versions of stuff, you're losing that testing that we're doing. So, we can't come back and say, yeah, we know that this is going to work with the version of Spark that you have in your cluster, or this is going to work with this or that, the other thing. So absolutely, I would definitely suggest if there is something, hey, we think we're running into this bug, those are my favorite support cases to get from folks. It's when they say, hey, looks like we're kind of running into this bug over here described. We see this error here. Could you, maybe give us a jar to, test it out, see if that fixes it for us. More than happy to do it any day of the week. Cool. All right. Well, I think that's all the time we have. So thank you all for coming out, and enjoy the rest of your evening.